So I want to go over another example of proof by induction. Remember, the idea of proof by induction is like an infinite long line of dominoes where you knock the first one over and then each one knocks the next one over. The theorems that we're trying to prove have the form P of n. So P is some sentence, some statement about n, and you want it to be true for all natural numbers n. The proofs by induction have two parts. In the first part, we show that P of 1 is true. So you show the theorem is true for n equals to 1. And then you show that if it's true for some number k, that P of k plus 1 is true. So whenever it's true for a number, it's true for the next number. So that knocks the next domino over. And then that's done. You're done, because since it's true for 1, and whenever it's true for a number, it's true for the next number, then if it's true for 1, it's true for 2, which means it's true for 3, etc. So let's see an example. This is the example I sent you. Excuse me. So the theorem is that if you add 1 plus 3 plus 9, up to 3 to the n, you get 3 to the n plus 1 minus 1 over 2. At this point, you should pause the video and check it for the case n equals 4 or 5. Just put in n equals 4 or 5 on both sides and see that they really are equal. That's okay, just pause the video. I'll wait. Okay, so what does the proof look like? Well, you say proof by induction. So the stuff in black that follows would be a formal proof. Red is commentary. So take out all the red and what's left, you got a great proof. So first you say, part A, the theorem is true if n equals 1. And you just write down what it says for n equals 1. 1 plus 3 to the first equals 3 to the second minus 1 all over 2. And you can leave it like this. You can trust that your reader can calculate both sides and see that they're both 4. Then you say, okay, we're going to assume that the theorem is true for n equals k. This is called the induction hypothesis. And you're thinking here of k as some particular unknown number. And the goal is to use the fact that the theorem is true for k to show that it's true for k plus 1. So by the induction hypothesis, we have 1 plus 3 plus 9, plus 3 to the k equals 3 to the k plus 1 minus 1 over 2. So we're just writing down what the theorem says if n happens to be the number k. And your goal, let's just peek ahead here, your goal is to get down to here, which is the theorem for n equals k plus 1. Replace all the n's by k plus 1's, and it looks like this. So you're starting here, and when you're starting a proof by induction, just write down what the theorem says for n equals k, and you're ending here, and when you're proving it, what you might do is write down the ending first. Write down the theorem for n equals k plus 2, and then see how you're going to get from one to the other. Okay, so back to our proof in progress. We've got a statement of the theorem for n equals k, and then we say, okay, how are we going to get down to here? Well, I'm going to add 3 to the k plus 1 to both sides. So I just did that. And the reader can see that, oh, the difference between this one and this one is just that I've added 3 to the k plus 1 to both sides. Now we do the addition on the right side of the equation. The left side now looks like the theorem for k plus 1. So we have to somehow show that the right side also looks like the theorem for k plus 1. So we do the addition on the right side and get a common denominator. So we take this 3 to the k plus 1 and write it as 2 times 3 to the k plus 1 over 2. And then when we add it, we have 3 to the k plus 1 here, and 2 times 3 to the k plus 1 here. So when you add, you get 3 times 3 to the k plus 1, and we still have this minus 1 all over 2. And then when you combine this 3 into the 3k plus 1, you get 3 to the k plus 2 minus 1 all over 2. So this left side is just the theorem with n equals k plus 1, and the right side is just the theorem with n equals k plus 1, and so we're done. Focusing on the first and last in this string of equalities gives us the theorem for n equals k plus 1, which is what we're trying to prove, and we're done. And so that's it. That's a proof by induction. If you'd like to see some more examples, just go to YouTube and type in proof by induction, or look in almost any math book, or look online elsewhere. There's lots of proofs by induction all over the place. But basically, it's this simple. Write down the theorem for k, try to show that from that you can deduce it's true for k plus 1. Okay, I look forward to seeing you.